So in this problem, we need to obtain the sum of the first n natural numbers. So when we consider our natural numbers, it will be 1 added to 2 plus 3 plus 4 all the way up to n natural numbers. So let's find out the sum of this particular n natural numbers. So for this, we'll have to use the formula, the sum up to the nth term, that's given by n over 2 multiplied to 2a plus n minus 1 times the common difference d. So in our case, our first term, so this is going to be the first term. So first term a is 1, then d, which is the common difference that can be obtained by taking any term and from it subtracting the previous term. So 2 minus 1, in this case we are considering the second term, and from it subtracting the first term, that's give us a value 1. Now we will substitute the value of a and d into our sum of the n term, such that we have s of n equals to n over 2 whole multiplied to 2 times a, so a is 1, so we have 2 plus n minus 1 times the common difference, that's 1. Solving this is going to give us a value n over 2 multiplied to 2 plus n minus 1, that is simply n over 2 multiplied to n plus 1. So that means sum of the n terms, sum of the n natural numbers has the value n over 2 times n plus 1. Right. So we can also understand this with the help of an example. Let's say we have n equals to 100. So the question is, if we have 100 number of natural numbers, we have 100 natural numbers, that means counting from 1 to 100, the sum up to the 100 terms will be simply equals to 100 divided by 2 multiplied to 100 plus 1. So 100 over 2, that's 50. So 50 multiplied to 101. So this is going to give us a value 5050. So let's move on to the next problem. Problem number 2. So here we need to obtain the sum of all natural numbers lying between 1 and 100, and they have to be divisible by 3. So let's begin. So here what we'll do, we'll consider the multiples of 3 between 1 and 100, because these are the numbers that are divisible by 3. So the lowest number will be 3, followed by 6, 9, and this goes all the way up to the last number, which is going to be 99. So here we have the sequence. This is an arithmetic progression. Now the task will be to find the sum of this particular expression. That means we have to add 3 plus 6 plus 9 all the way up to 99. For this, we need the value for n. Now to find out the value of n, we are going to use the formula an. The nth term is given by a plus n minus 1 times d. Now the first term a, that's simply 3. The common difference will be 6 minus 3, which is equals to 3. Then we also have our last term, or the nth term, so that's 99. So substituting all these values into our equation, we have 99 equals to 3 plus n minus 1 times the common difference 3. So 99 minus 3, that's 96. 96 is equals to n minus 1 times 3, or simply 90n minus 1 will be equals to 96 divided by 3. So 96 divided by 3, so that's 32, which means solving for n, we get 1 plus 32, which is 33. Now that you have the value of the total number of terms, so that means there are actually 33 numbers between 1 and 100 which are divisible by 3. We can easily find out the value of S33. So this is going to be equals to 33 divided by 2 multiplied to the first term, which is 3, plus the last term, which is 99. So 33 divided by 2 multiplied to the 99 plus 3, so that's 102. So 2 times 51, that's 102. So we have 33 multiplied to 51, and this is going to give us the value 1683. So that means the sum of all natural numbers between 1 and 100 divisible by 3, that's going to be equals to 1683. Let's move on to the next problem. Problem number 3. We need to obtain the sum of the first n odd natural number. So let's begin. Now here, the first natural number that's odd is going to be equals to 1. Then we have, since we are trying to find out the sum, so this will be added to the next odd number, which is also a natural number, that's 3. Then the sequence, the next one will be 5, followed by 7, and this goes all the way up to n number of terms. Now what we have to do, we have to find out the sum of this particular arithmetic progression. Here we have our first term, that's a. The common difference d will be equals to 3 minus 1, which will be equals to 2. So that means our sum up to n number of terms, this is simply equals to n divided by 2 whole multiplied to 2a, so 2 times 1 plus n minus 1 times the common difference, which is 2. So that will be 2. This is going to give us the value n over 2 multiplied to 2 plus 2 multiplied to n minus 2. So here 2 and 2 gets cancelled, so this leaves us with n times 2 times 2n. So the 2 and 2 will get factored out, and this leaves us with the value n squared. So that means the sum of the first and odd natural number, this is going to have a value of n squared. Let's go to the next problem. Problem number 4. We need to obtain the sum of all odd numbers between 100 and 200. So let's begin. So here, the first number after 100, that's an odd number, that is going to be 101. Since we're going to we have to find out the sum, so we'll add it to the next term, which is also going to be an odd number. That means we have 103 in the sequence, followed by 105. And this will go on up to the last odd number, which is less than 200, 200 being an even number. So the odd number less than 200 is going to be 199. So we have to find out their sum. For this, we will need to obtain the total number of terms present in this particular series. That means we need to find the value of n. So here, our first term, a, that's 101. The common difference is going to be equals to 103 minus 101, which is equals to 2. And we also have the nth term, which is the last term, that is 199. So using the formula an equals to a plus n minus 1 times the common difference d. Here we have 199 equals to a, which is 101 plus n minus 1 times the common difference t. So 199 minus 101, so this is going to be equals to we have 98, which is equals to n minus 1 times 2. So n minus 1 will be equals to 98 divided by 2. So that will give us n equals to 1 plus 98 over 2. So that's 49, which is equals to 50. So that means there are 50 terms between 100 and 200, which are odd natural numbers. So let's try to find out the sum. The sum will be simply equals to n over 2 multiplied to the first term added to the last term. So here our n value is 50, so s50 will be equals to 50 over 2 multiplied to 101 added to 199. So we have 50 over 2 multiplied to 101 plus 99, that's going to be 300. So we have 2 times 150 is 300, so 150 times 5, so that's 7500. So this is going to be the sum of all odd numbers between 100 and 200. Let's move on to the next problem. So problem number 5, we need to obtain the sum of all odd numbers between 1 and 1000 that are divisible by the number 3. So let's begin. So first we will state all the numbers, the odd numbers between 1 and 1000 that are divisible by 3. To do that, all we have to do is take the multiples of 3. So the multiples of 3 are 3, 6, 9, 12, 15. And this goes all the way up to the last one, the number which is less than 1000, here are also divisible by 3. So that's 999. But here we only have to consider the odd numbers. So we cannot consider 6, 12 and the rest of the numbers. So our new sequence will be 3 plus 9 plus 15. This goes on and on to the last 999. The last number is 999. So we need to find out the sum of this particular series. Let's do that. So here we'll have to first obtain the number of terms present here. For this we will need the first term, which is 3, the common difference, which is 9 minus 3, that's equals to 6. We also need the nth term, so nth term is 999. Now using the formula an equals to a plus n minus 1 times the common difference d. So our nth term is 999, so that's equals to 3 plus n minus 1 times the common difference, that's 6. So 999 minus 3, that's 996, equals to n minus 1 times 6. Solving for n, we'll get the value 167. So now that we have the value of the number of terms present, so we will obtain the sum of the 167 terms, and all these terms are lying between 1 and 1000 and also divisible by 3. So this is given by, we have 167 divided by 2 multiplied to the first term plus the last term. So this is going to give us 167 divided by 2 multiplied to 999 plus 3, so that's 1002, which is going to give us the value 83,667. So this is the sum of all odd numbers between 1 and 1000 that are divisible by 3. So let's move on to the next problem. Problem number 6. We need to obtain the sum of all integers lying between 84 and 719 such that these numbers are divisible by 5. So let's begin. So we'll first consider the number which is greater than 84, because 84 is not divisible by 5. Just to remind you, any number which has last digit as either 0 or 5, those numbers are going to be divisible by 5. So the number which is greater than 84 is 85, and since the last digit or the digit in the units place is 5, so this is going to be divisible by 5. Then the next number is going to be 90 followed by 95, and this goes on. Then we'll have to come to the number which is less than 719, because 719 is not divisible by 5. So we will consider 715, and since the digit at the units place is 5, so this is going to be divisible by 5. So now that we have this number, so this sequence, these numbers are in arithmetic progression. Now our task will be to find out the sum of all these terms. That means 85 plus 90 plus 95 all the way up to 715. Now to find out the sum, what we need is the number of terms. To do that, we can find out by using our nth term. Our nth term is given by 715, which is the last term. So this will be equals to the first term 85 plus n minus 1 times the common difference. The common difference is going to be 5. That's because these are all multiples of 5. So that means 715 minus 85, that's equals to n minus 1 times 5, or simply n will be equals to 715 minus 85 divided by 5 plus 1. So let's solve this, and this is going to give us a value 127. So that means there are 127 terms between 84 and 719, and all of these terms are going to be divisible by 5. So let's find out the sum. So we have s 127, so this is going to be equals to 127 divided by 2 multiplied to the first term plus the last term. So let's find out this value. This is going to be 50,800. So this is the sum of all the terms between 84 and 719 that are divisible by 5. So let's move on to the next problem. Problem number 7. So this time we have to find out the sum of all integers lying between 50 and 500, and these have to be divisible by 7. So let's first try to figure out the given sequence. A number which is greater than 50, because 50 is not divisible by 7, the number greater than 50 which is divisible by 7 is going to be 56, followed by the next number which is going to be 63. Fine. Then we have 70. Then we'll keep on going, and the last digit and the last number which is going to be divisible by 7, so it's not going to be 500. 500 is not divisible by 7, but the number which is less than 500 and divisible by 7 is going to be 497. So these are the numbers that are in arithmetic progression. That means we can quickly obtain the first term, which is going to be 56, and the common difference is going to be 7, because these numbers are divisible by 7, and our last term or the nth term is 497. We can find out the value of n. So we have 497 equals to 56 plus n minus 1 times the common difference d, which is 7. So that means n value can be obtained by 497 minus 56 divided by 7 plus 1. So let's find out the value of n. So n will be equals to 64. So that means there are 64 terms present between 50 and 500 which are divisible by 7. So our now goal will be to find out the sum of these 64 terms. That means we'll add 56 to 63 plus 70, and it goes all the way up to the last term, which is 497. So the sum is very simple. All you have to do is take, since we have 64 terms, we have 64 divided by 2. This will be multiplied to 56 plus 497. So let's find out this value. This will be 17,696. So this is the sum of all the integers between 50 and 500 that are divisible by 7. So let's move on to the next problem. Problem number 8. So we need to obtain the sum of all even integers lying between 101 and 999. So let's state all the numbers that are even and lying between 101 and 999. That is going to be 102, 104, 106, all the way up to 998. Now here, these are in arithmetic progression. So that means we can quickly find out the value of n. So our first term is 102. The common difference is going to be 2. And the last term is 998. So that means an, which is 998, that will be equals to the first term plus n minus 1 times the common difference, d, which is 2. So n value will be 998 minus 102 whole divided by 2 plus 1. So let's find out this value. So n will be equals to 449. So that means there are 449 terms between 101 and 999, and that are even integers. So now that we have the value of n, so our s 449, the sum of all these terms, that will be equals to, we have 449 divided by 2 whole multiplied to the first term plus the last term. So this is going to give us a value 246,950. So this is the sum of all even integers lying between 101 and 999. Let's move on to the next problem. So problem number 9, we need to obtain the sum of all integers lying between 100 and 550 that are divisible by 9. So let's begin. So the number 100 here is not divisible by 9. The number which is divisible by 9 is going to be 108. Then the next number which is divisible by 9, all we have to do is add 9 to 108. So that's going to be 117. And then again adding 9 to it is going to give us 126. So these are the numbers that are divisible by 9. And the last number which is divisible by 9, and it cannot be 550, but it will be less than 550. That's going to be 549. So now that we have the numbers, so this is a sequence that is in AP, so that means these numbers are in arithmetic progression. So our first term is going to be 108. The common difference is going to be 9, and the nth term is 549. So we can find out. So we have the value of n, the number of terms will be 549 equals to 108 plus n minus 1 times the common difference d. So n value, so here d is 9. So n will be equals to 549 minus 108 whole divided by 9. And this entire expression will be added to 1 to get the value of n. So n value will be equals to 50. So that means there are 50 terms, 50 integers between 100 and 550 which are divisible by 9. Now that we have the number of terms, we can find out the sum. So as 50 will be equals to 50 divided by 2 multiplied to 108 plus 549. So that means the value is going to be equals to 13,925. So this is going to be the sum of all integers lying between 100 and 550, and these numbers are divisible by 9.